Chapter A, Functions. In the introduction, I mentioned function f of x, that stands for function, and we let the values be represented along the y-axis. We say y equals f of x, and then this is the x-axis. Sometimes you see an arrow here, an arrow there, and this really means x-axis, and the specific values of x would be along the axis. So here, for example, that could be x right there if we want to pick a sample point. But often we leave out the dash axis, and that implies that means x-axis, all the values of x. And then when you put the x underneath, it means a specific value of x. And the specific value of y would be right here. And then at this point, you could say x comma y, where you list the first value as x and the second one's y. We call that an ordered pair. The order is important, that the x comes first and y comes second. So the concept of a function is, I like to think of it as a machine, where you put into the machine an input, which we call x, and the function f works on x and then sends out an output, which is f of x, which we call y. So we can simply refer to the function as the f function, f of x, which is going to then take the x, eat it up, and transform it, and out comes f of x, which is y. So we write down y equals f of x. Now, it's important to note that only one value of y, or the output, comes out. You can't have multiple outputs. In other words, just one output. But you can have for two different x's the same output. It's just that when things come out, you're only going to have one value. So that means when you have a graph, say, I've put here y and x, we can't have something that goes straight up, because see, then x would have, what's the y value? I see lots of y's here. So we're not going to have that. We're going to have things that go more like this, say y and x. And you could have something flat, where then when you put in values for x, you get here whatever that y is. That's a constant, and that's not a problem. So let's look at that first. Y is a constant. So I like to make these little tables where you have x and y, and you pick an x, say, and you're going to write down what the y would be. Say if I have minus 4, say the y is 2. And say minus 3, the y is 2. This is going to be a constant function. 2 is coming out all the time. And then see if I go to 0, out comes a 2. 1, out comes a 2. If I have, say, here 3, out comes a 2. So when you have this little table, which in my notes that you can download for this, I have the table going, I have the table here going left and right, so it doesn't matter which way. Then what you do is you can come over here and draw your x and y. And then here, for the different values, you can actually put the values on the graph. Say like here's a minus, say that's a minus 2, a minus 1, a 0, and then 1, a 2, and a 3. Then if you have 0, say the answer is 2, so that would mean you'd be up here at 2. And then if you had 1, you're up there at 2. Now, if you do these points and you do them close, if they're close together, you can, you draw a smooth, curve, we say, through them. But in this case, it's very simple. They're all the same. So you just draw a straight line through them. And that is an example of a function. That's our first function. And that function is y is equal to 2. Or you can write for y f of x, if you'd like, that's fine. F of x is equal to 2. Now the next case we're going to look at is a general linear function. This one is flat, but let's look at one that is at some angle. All right. So I'm going to go ahead and sketch one first. So here is x, and here is y. And let's go ahead and say we have 0, 1, 2, 3, and a 4. And let's go in the negative direction. 1, 2, 3, 4. So -1, -2, -3, -4. And let's say we're going to, well, I have to label some of these. 1, 2, 3, 4, 5. All right. And let's go here, -1, -2, -3, -4, -5. So this is -5, -4, -3, -2, and that -1 applies to both of those, and the 0 applies to there. There's a 0. All right, so let's say we're at 0. Let's say at 0 we're at -2. So I can make a point there. And let's say when we are at 2, we're at 0. And the function we're looking at is a straight line, so it would go like this. So this function here went up 2 and went over 2. So if I want to keep that in the same line, if I go over 2 to 4, I would need to go up 2 more. So that's straight line. All right, so that would be go up 2, and then there's 2. And then that straight line there, that would like continue on. And then this way we continue in reverse. So this function here, we can write down some values. We can write down here, for example, if we have x and cy. So looking at this graph, say we start at -2 for x. Let's say x is a -2. If x is a -2, the way I've constructed this graph is that if I go out 2, I go up 2. Well, that's saying if I go out 1, I go up 1. So here I go from 2 to 3, I'm up by 1. Go from 3 to 4, I'm up by 1. So if I'm at 0, I'm at -2, then I'm going to be down by 1 here at -1, that's -3, and then by -2, I'll be down by 2. So that's going to be -4. Then at -1, I'm going to be down here to -3. Just think every step to the right, I've designed this to go up by 1. So if we go from -2 to -1, you just add 1. And then if you're at 0 here, x is 0, you're at -2. And see how that's checking out? You're simply adding here 1 every time you go one step in the x direction. So here if I go from 0 to 1, then if I add 1, I'm at -1. Then if I go to 2, here, I'm at 0. If I go to 3, I went up 1, I'm at 1. And if I go to 4, then I go up another 1, I'm at 2. So these are the values, the ordered pairs that go with this. So if you think of this, say in terms of y and x, you're basically taking your x value and you're subtracting 2. 4 minus 2 is 2. 3 minus 2 is 1. 2 minus 2 is 0. 1 minus 2 is a -1. 0 minus 2 is -2. -1 minus 2 is -3. -2 minus 2 is -4. So the graph would be, if we were to write it out, y is equal to whatever the x is, and you subtract 2. So that's the function of this line. So the definition of our slope remember, is the rise over the run. So here, whenever you run out by 1, you go up 1. So in other words, the slope is 1 over 1. It's just 1. If I go from 3 to 4, that's 1 unit of run. If I run out here 1 unit, I go up 1 unit. See? So this is happening at all places. This is the situation. Say, very, very nice. Say, that's there. You could go up here like this. You could make all those little triangles that represent 1 unit for a run and 1 unit up. So the slope is 1, and that is what we see here as a 1. If we had replaced that 1 with a 2, then you would be going up 2 instead of 1, and it would be steeper. So the general form of the straight line is some slope we call mx, plus, and then what do we add here? Well, whatever this is in general can be a plus b. In this particular case, the b is a negative 2. We call this, since it's dramatically where you cross the y-axis, it's where you intercept the y-axis, we call this the y-intercept. And m is called the slope. So we have now the two simplest functions. One, y equals a constant. If I replace that 2 with some constant c, I could just say y equals c, just some constant. The next one has an x term plus a constant term. The b here is a constant. In fact, if you want, you could call that you can call that cb if you like, since that is also the y-intercept. It's going to be the constant everywhere. And here what we did is we added an x term. And you might guess that the next thing could be to add the x squared term. So here, if you wanted to solve an equation to find where y is equal to 0, like this, a lot of times in physics we're actually trying to find an equation where something is equal to 0. Then, if y equal to 0, then you could find what the b is. Watch this neat thing. 0 is mx plus b, and then you would subtract b from both sides of the equation. In the old days in high school, we used to have a little shorthand to say subtract b, or subtract 2, or subtract 3, in this case b from both sides of the equation. Then you would get minus b is equal to mx, and then to get the x by itself, the solution, you would then divide both sides by m, and that would be minus b over m is equal to x. So what this has given us, x equal minus b over m, this has given us here where you cross the x-axis. Because when y is equal to 0, you're along the x-axis. So we already know where it crosses the y-axis, but we don't know where it crosses the x-axis. So we want to find a formula for that. So by setting y equal to 0, then you have to be along this x-axis somewhere. So you put y is equal to 0, and then you solve for the x, and you find this is the answer. Well, let's see if that checks out for our case. For our case here, we know the answer is 2. But in our case, the function, what was b? B was negative 2. So to apply this for our case, the minus sign is there, and the b is negative 2. And then what are we dividing by? The slope, that's the 1. So if you do that, the two minus signs cancel and you get 2, which is exactly what we have. Now for the next case, I'm going to add an x squared term. So I have ax squared plus bx plus c. So we have now a constant term, we have a linear term with the x, and now we have an x squared term. And I picked a real simple one here. Y is equal to x squared. So if we look at this graph here, when x is 0, 0 times 0 is 0. In fact, you can look at the table first. If x is 1, 1 times 1 is 1. If x is 2, 2 squared is 4. And then 3 times 3 is 9. 4 times 4 is 16. And since it doesn't matter if it's x is plus or minus, you get the same answer, then there's a reflection symmetry here about this y-axis. If you look to the left and the right, you see you get this nice curve that then comes back up. And here, if x is 4, then up here is going to be 16. If x is 2, like here, 2, then you're going to have 4. And it's a nice graph. It's called a parabola. And notice that if you subtract 6 from this, you basically lower everything. So that's what I did down here. I have x squared minus 6. So everything we had before gets lowered by 6 since you're subtracting 6. Isn't that nice? Very nice effect. Now in my text I have a more complicated one where I have x squared plus 2x minus 3. And, worked out some of the values for you in the text. And I encourage you to, look at the text and study this. And this one here, when you plot it, is somewhat lowered, but also shifted to the left. Now, what's an interesting thing to do, and what arises often in physics and engineering, is to find the solution when y is equal to 0. So that would put you along the x-axis. You're looking for these 2 points. So if y is equal to 0, you would have then here, you would have x squared plus 2x minus 3 equal to 0. Now, you learn in algebra how to factor, and that would be helpful here to do this. What you do is you say, this comes from 2 binomials, a term that has 2 things. And if I have an x here and I have an x there, x times x is x squared, I would get this. But then if I have a number here and a number there, I would have to have that number times x and this number times that x and add them together. And then when I multiply these 2 numbers, I would need to get -3. So you guess a little bit here. Say, suppose that we have a 3 here and a 1 there. 3 times 1 would be 3, but I have to get -3. So that means one of these has to be a plus and one has to be a negative. And once again, we're guessing. If this is a +3 and this is a -1, that answer actually is going to be the one that works, because 3x minus x is 2x. Now suppose I did that the wrong way, and I first of all guessed with the minus sign and plus sign flipped. Well, when I multiply this out, I would still get x squared. I would get here -3, because see, I have 4 terms here, x times x times 1, -3 times x, and -3 times 1. So I'm looking at the x times x first to get the x squared term, and that's going to be there. And I have -3 times +1, that's -3. But now I have a problem, because this is here -3x plus 1x is going to be a -2x. I don't get that. That's a wrong answer there. So if I have -3x plus x, we call those the cross terms. That's going to be -2x. That doesn't agree. So this is the correct answer here. Well, for this to be 0, we can either have this first one being -3, first one being 0, so that would be x is -3, or we can have x equal to 1, and then you get 0. And let's look at this graph. If x is -3, sure enough, that is one of the answers. And if x is equal to 1, that is also one of the answers. We labeled our x's down in here, down at the bottom. So x is equal to 1, we're up here. X is equal to -3, we're up there, which is the 0 point in each case. Now at this point, I want to show you that in general, by using the quadratic formula, you can find the zeros to be given by this formula in general for this solution. Now I have a separate YouTube video, which is here. You should go to, that's in my channel to see this. This is a very powerful formula used very often in physics and engineering. So it says minus b plus or minus the square root of b squared minus 4ac is over 2 are your two answers. Now that's for when you have your general form ax squared plus bx plus c equal to 0. Well, let's look at this case. In this case, the a is 1 and the b is 2 and the c is -3, just to use the case that we have studied here for this graph. Well, if we do that, we would find that we get minus b, which would be -2, plus or minus the square root. We would take then b squared, that's 4, and then subtract 8 times c. So minus 4ac with the minus sign. Now a is 1, c is -3, so if I multiply a times c, I get -3. This minus sign will cancel that minus sign, but then I have 4 times 3, which would be a plus 12, and that's all over 2. Now 4 plus 12 is 16, so this is -2 plus or minus the square root of 16 over 2, and the square root of 16 is 4. And I could simply do that this way by dividing by 2, -1 plus or -2. So that means the answers are -1 plus 2, which is 1. That's this one here. Or -1 minus 2, which is -3, which is this one here.